That's a great question. So let's take a look at why, God, that shadow's driving me nuts. Why that isn't the case.
Okay.
So this one, we have the big mass is on the left and the little mass is on the right. I'll label them the same way they did. Mass 1, mass 2. And so they want to know, so friction, force of friction is 0. And we're going to apply some sort of horizontal force, so level with everything. And the horizontal force is either going to go that way or that away. So the magnitude of the forces, so we want to know force of 1 on 2. And does it change depending on where I'm pushing? So you good with that so far?
Yeah.
Okay. So the first thing you always want to do is a free body diagram. So force gravity, force normal, doesn't matter because there's no friction. So this will be mass 1. And then mass 2, same thing. It's gravity, force normal. The difference here is if I'm pushing this way, my force applied is this way. Then I have on mass 1 a force applied. And then I have from mass 2, force of 2 on 1.
Mm-hmm.
So I don't know if you heard the other discussion we were having, that this is a third law pair, this interaction between 1 and 2.
Action reaction pair.
Yep, yep. So that means that I have a force 2, 1 acting on this box.
Mm-hmm.
So I can flip it around if I want and think of it as the mass of 1 pushing on 2, or I can just remind myself that that force is going to be equal and opposite of that force.
Mm-hmm.
You good with that?
Yeah.
Okay. So then this is mass 2. And so now I can do my sum of forces. And actually, I'm just going to focus on this one here because that's the one that's going to help us see what's going on. So I have, let's see, this force 2 on 1 equals mass 2 times acceleration. And if I'm going this way, then the acceleration is positive. So let's just make sure I'm clear about this, that I'm saying to the up and to the right is positive.
Mm-hmm.
So not worrying about this one. The only thing that's going to change if I push this way, so now if I push to the left, I have this exact same setup, just reversed.
Mm-hmm.
So now I'm pushing on mass 2, and my force normal I have, so force of mass 2 on 1, force of 2 on 1 equals mass 1 times acceleration. And I'm going that way. And in this way, let's just be clear, this time I'll define to the left as positive.
Mm-hmm.
So when I look at their normal forces, what I'm seeing is that the normal force between them, because they have the exact same acceleration, otherwise the boxes would be getting all smushed, is that, let's see, mass 2 is smaller. So if mass 2 is smaller, this force applied, I'm sorry, the force of 2 and 1 is going to be smaller than this one.
Okay.
Okay. Another way to think about it is I'm applying the applied force to the bigger mass. The only thing resisting it is the smaller mass. When I go this way,
Mm-hmm.
if I push this way, I have, going to the left, I have that bigger mass resisting that push.
Yeah.
So you good with that?
Oh yeah, sorry.
Okay. Yep. So that's all it's asking. So if I push to the left, then the correct answer is that the force normal between these two is going to be larger, and it's because the larger mass is the thing that normal is accelerating.
Okay.